Good afternoon to all the participants present over here. I hope all of you had lunch. Now we are going with the second session of our SGTP. So the title, the person who is going to provide the information about power quality issues in India and application of IOT to enhance power quality is Dr. G. Balamurali. And I request Dr. P. Usharani, the convener and professor, R.M.D. EEE department, to kindly provide the introduction about the chief guest. Thank you, madam.
Very good afternoon to all participants and today's speaker, my friend Dr. G. Balamurali. Let me brief about professor's profile. Dr. G. Balamurali sir has completed BE from GCT 91 batch, ME Applied Electronics from GCT 94, PhD in the area of power system and power management, that is Master of Business Administration, Power Management in the year 2004 from Center for Advanced Management of Power Studies, that is National Power Training Institute under MHRD, Ministry of Power, PhD in the year 2013. He is now working as an executive engineer in TNEB. He's having, from the beginning, he was in TNEB for more than 20 years, more than 25, I think so. His area of interest, planning of power system infrastructure, power business management and energy economics. He has conducted various training sessions, delivering sessions in various conferences, FTPs, on the subjects of power quality, power system studies, application of IOT in RES, electrical safety, transmission and distribution system, quality enhancement in teaching methodology, quality enhancement in assessment and evaluation methodology of learning in higher education institution and career ideas and options to outgoing engineering students, delivering guest lectures in universities, union government organizations, national level organizations, BIT, Regional Training Institute, National Productivity Council, apart from engineering colleges. For training sessions delivered in so many in TANTRANSCO, for the staff members. In Anna University, he has handled the special elective subjects, urban and rural energy management and energy economics, financing and regulations to postgraduate students in power engineering and management. He has specially designed training programs per annum for TANTRANSCO engineers on recent advancement in technologies and current changing trends and best practices in utilities. Was deputed to occur MBA in Power Management conducted by the National Power Training Institute, Faridabad, under the Ministry of Power, and was given Scroll of Honor for the meritorious performance in the MBA in Power Management for standing first in the class and awarded gold medal. The TANTRANSCO awarded Certificate of Excellence, the Golden Jubilee Certificate on 2007 in recognition of excellent service rendered. He has visited throughout India. He has visited so many power stations, NTPC and power stations, participated in the International Visitor Leadership Program on Climate Change and Renewable Energy, which was taken place in the United States from June 8th to 26th, 2015. Of Educational and Cultural Affairs, U.S. Department of State, Washington, D.C. organized the above program. Besides, 21 participants other than him from different countries have participated in the same program. The participants have visited Washington, D.C., Buffalo, Denver, and Boulder and Hawaii. This project has explored in policies and responses to climate change through advances in renewable energy technologies, economic and regulatory incentives, public awareness, and changing patterns of energy use. He was one of the curriculum framing committee members recently, 2017 regulation also recent also along with the team. I request Dr. G. Balamurali, Executive Engineer, on behalf of our management and college and on my own behalf, I welcome you, sir, for your busy schedule. You are accepted for our invitation and delivering the session. Please, sir. Kindly take the
Thank you,
session,
Professor.
sir.
Thank you very much. Thank you, Professor. Thank you very much for the introduction. So today's topic is power quality issues in India, application of IoT to enhance power. The next 2 hours will be what are the issues we are facing in India with respect to power quality, and then how we can implement IoT in the power sector to enhance the power quality. That is the idea of this entire presentation. I'm not going to talk about any basic fundamentals, but however, the prime issues which are revolving around in the power sector with the power quality we will discuss in the next 2 hours. First, our grid is a complex grid. What it means? It's a simple grid. It's a complex grid. Why it is complex? Every day the complexity is getting increased. With respect to 20 years back, the grid is totally different. But for the past 10 years, every day grid is getting changed. Now it is too complex. Why it is too complex? We will see. Say, because of the penetration, there's a large integration of renewable energy capacity into the grid. So 20 years or 25 years back, there was no such renewable energy integration. It may be very less, very minimum 4,000 or 5,000 megawatt. But as of now, it is very high. So large penetration of renewable energy into the grid made the grid as a more complex grid. So the first point. The second, you can see distributed generation. It is not at a particular location. This entire grid distributed different locations, generation and distributed generation. That is also increasing the complex grid. And again, on those days, the voltage level will be 11 kV, 22 kV, 33 kV, or 110 kV. But now, 110 kV, 230 kV, 400 kV, nowadays it is 263 kV. More higher voltages is the power transmission system. And then loads are also changing. On those days, it was very simple linear load. And then gradually changed to non-linear load. Now, more of non-linear load with very minimum of linear loads. So the complexity is getting increased because of the large penetration of renewable energy, and generation is distributed throughout the grid, and then high voltage level for transmitting the power in the transmission system, and then the entire use pattern, that is the loads which are present in the distribution system, it's also getting changed towards the complex non-linear loads. These are some of the reasons. That's why we are calling this grid as a complex grid rather than a simple grid. Okay, how it is related to quality? All this complexity creates more problem into the grid. So it is creating nuisance from the point of power quality. Thus, because of this complexity, power quality issues to the fore. Because of these challenges, it has become even more difficult to maintain the power quality in the country. Because of this continuous integration of renewable energy, distributed generation, higher voltage power transmission system, and complex. So these are the 4 prime areas. Because of that, the quality of the delivered power is getting affected. So here you can see coal, it's about 53% in the country, coal-based thermal stations, lignite-based 1.78, gas 6.7%, oil 0.1. Put together, 62% of our total installed capacity is from thermal stations. So we have a 3,71,000 megawatt total capacity, installed capacity in the country, of which 62% we are getting from this thermal-based energy. Hydro, renewable energy, it's about 45,000 megawatt. It's about 12% we have a hydro power stations. Nuclear, it is less than 2%. Apart from that, we have a renewable energy system, which includes solar, wind, or industrial and urban waste, biomass gasifier, and small hydro project. Put together, we have a 87,000 megawatt. It's about 23%. In the sense, 1/3 of, say, 1/4 of our total installed capacity, 25% is from renewable energy of solar and wind, and 12% from hydro. The rest is from black power or It's a thermal based power. What's the significance? Why we have to discuss this install capacity with respect to power quality? What it has? Is there any relevant, which are relevant? Say, if you want to improve the quality, you have to think about which plant is going to operate as a base load, which power plant is going to operate as a peak load. That is also matters. So here, our base load power plants for the past 10 to 20 years, we are maintaining base load power plant as a thermal load power plant. Peak load, say 62% is coming from thermal section, which is acting as a base load power plant. Peak load, based on the water availability, it is the hydro power plant which may operate as well as peak load, predominantly peak load, instant load. Whenever we need power, we can switch off. There's other requirement. The nuclear is very minimum, it's 1.82%, it is continuously running. But think about the renewable energy sources, it's about 25%. But it's an infirm power. No one knows when the power will be available. Sometimes if there is clouds, we can expect good power from the solar stations. If it is a rainy season, we cannot expect power from the solar power plant. Wind power plant, it produces high wind power only during season, say for example from May to September. Other than the wind season, the production may be 20% or 30%. But during season, it may be 60 to 80%, the full capacity, the maximum full capacity. In the sense, these renewable energy sources are not a fixed one, it is an infirm power based on the season or based on the availability. So, solar radiation. So, even then, nowadays, if you want to get more clean power and green power, the entire society is safeguarded only when we are producing power through green power. It means we have to increase the quality, increase the quantum of power generated through green power or clean power, which is nothing but a renewable energy source. But again, it is an infirm power. What to do? That's why we have to tackle the issue in a different way. So as of now, we have renewable energy other than hydro. The solar is 35,000 megawatt, wind is 37,000 watt, biopower is 10,000 megawatt, small hydro is 4,000. Put together, we have 88,000 megawatt of renewable energy other than big hydro power plant of 45,000 megawatt. Put together, about 1,30,000 megawatt of power we have in the grid with renewable energy. Wind and solar alone, it is about wind, solar and biopower, it's alone 88,000. But the country, we fixed the target in the year 2016 of 1,75,000 megawatt by the year 2022. We are already in 2020. Within another 2 years, we have to double the capacity. In the sense, from 88,000 to 1,75,000. It means all the power, these powers are flexible power. It is an infirm power. We may not get a continuous power, but even the penetration of this such power are going to increase the double that time over the period of 2 years, because we need a clean power. We don't want a black power. We don't want to pollute the environment. It means we have to promote the clean and green power only. So that's why we are interested. It's against the free power. So we are interested to create more capacity in solar and wind, thereby making the capacity double the time as 88,000 by the after 2 years, it's 1,75,000 megawatt. It means the solar power may be available during morning, daytime. Night, we may not get the power. Today, we have a solar power of 35,000 megawatt. You assume 60% efficiency. 0.60, about 18,000 megawatt. In the morning, you are getting daytime. Night, if you are not getting this 18,000 megawatt, what will happen? Where we have to move? Similarly, wind. So we have a 37,000 megawatt. You assume efficiency of 0.6 to 0.7. Say about 20,000, 24,000 megawatt if we are drawing. Suddenly, if there is no wind season, after September, we may not get the power from the wind power plant. It may be less 30% or 20% only. How to manage the grid? How to manage supply with the demand during the absence of this renewable energy? It's a critical point. We have to absorb the renewable energy one point of time. The other point of time, we have to manage the grid to balance the generation with the demand. That is also critically we have to manage. So these are some of the issues which makes the grid as a complex grid. You can see here, just 10 years back, 2013, it was only, including the large hydro of 48 megawatt, the total capacity of the renewable energy is only 60,000 megawatt. But as of now, 2019-20, it's about 1,30,000 megawatt, 1,30,000 megawatt, including the large IOT. It means over the period of 7 to 8 years, we almost more than doubled the renewable energy capacity. It means the penetration of renewable energy is double the time. It means flexibility and infirmness is increased in the grid. You can see how our total supply position in the country for the past 10 years, the corresponding period. On those days, our demand was only 1,20,000 megawatt. We supplied about 1,04,000 megawatt, about 15,000 megawatt shortage, put together 12% shortage. But over the period of 10 years or 12 years, we gradually increased our install capacity. Thereby, we matched the peak demand. So as of now, it is 1 lakh. Last year, it is 1,83,000. We met 1,82,000 megawatt. About 1,000 megawatt shortage. It means only less than 1%. So over the period of 10 to 12 years, we reduced our shortage from the 12% to 1%. Now, presently, it is less than 1%. It means we created adequate capacity. We have given more focus on creating capacity. Thereby, we want to fulfill the peak demand, but we are never bothered about the quality of supply. We bothered only, first we have to provide the supply, whether it is a quality power or if it is not a quality power. First, provide power. That is the provide 24/7 power. That is the first objective. That's why we created more capacity over the period of time. That's why we reduced our shortage from the point of 12% to 1% over the period of 12 to 13 years. Similarly, if you think about the requirement, million units, on those days, 10 years back, our demand was, our million requirement was 8,30,000 million. But last year, you just see 12 lakhs million. It means per month average, 1 lakh million unit people are consuming. But what we are supplying, we are able to supply almost everything. It is less than 0.5% only we are unable to supply. In the sense, 1 lakh million unit every month throughout the country, about 130 crore people are consuming. Per month, 1 lakh million unit. Per annum, it is about 12 lakh million unit. We are able to fulfill the need of the people at first instant. But now, it is a time to think about how to provide a quality power. Quality and reliability has to be improved. On those days, the continuous provision of supply and making power available 24/7 without any shortage was the objective. But now, the objective is moved from fulfilling the power requirement to providing quality power. That's why everywhere we are giving more focus on providing how to provide a quality power to the consumer. So now we are coming power quality. Generally, suppose if you study from the books and if you are a profession by way of academician, your way of defining power quality may be different in depth. But in general, if we define from the power sector point of view, what is meant by power quality? You can see here, in India, power quality is often described in terms of power factor. Predominantly, we are considering power factor, frequency, and reliability and restoration of supply. It means, what is your power factor? If you are not maintaining power factor within the limited level, you will be penalized. So, power factor, maintaining power factor by the end consumer, that is most important. Frequency, the supply frequency has to be maintained by the utility. There should not be any deviation. That is also considered the power quality. So, power factor, frequency. Then reliability. It means without any interruption, we should not, the utility has to provide the power continuously without any much interruption. If it is an interruption, it should be with a limited level. Number of interruption is also most important. Again, how quickly we are restoring. The interruption may be 1 or 2 days, but if you are restoring it after long duration, it affects the performance of the other industries. So, these are the major factors which coins the word of power quality. Power quality means from the point of power factor, from the point of frequency, from the point of reliability, from the point of how quickly we are restoring power. These are the parameters we are taking into account from the point of power quality when it is defined by the utility person. Suppose if we are defining the power quality by an academician, many other points we have to take into account. But at first instant, we are giving more focus for these factors. And second instant, we are very clearly we have to monitor all the parameters and ensure all the parameters should be within the limit. We will see one by one. Now we are having common power quality problems. Say residential, you assume normal residential consumer or industrial consumer. How we perceive, what we will see as a power quality problem. We will see one by one. Common power quality problem, supply interruption. Suppose I am giving this presentation. You are listening. In between, if supply is interrupting, that is a power quality problem. Harmonic discharge. Now we are having the fine print. Harmonic. Instead of fundamental frequency, if there is additional frequency in the voltage or current, which is called harmonics, if it is present in the system, that is also power quality problem. But the common man may not know it is because of harmonic. But if you are using a highly sensitive electronic equipment, at that time, if there is variation in voltage, fluctuation in voltage, if there is a device, at that point of you will come. These are the things which are happening just because of the component of harmonic discharge. Transients and imbalance in voltage and current. All the three phases voltage may not be the same. Flickers. If your bulb is flickering, voltage sags and swells. Suddenly the voltage is getting boosted or is reduced. These are some of the problems. Frequency variations, and apart from that, react. These are some of the things which are considered as a common power quality problem. But it has an impact on operational impact on system network. If there is more reactive power, what will happen? If there is a less reactive power, what will happen? Then how to manage the system to maintain the power factor, to maintain the reactive power, to maintain the voltage level. So voltage should be within the limit. It should not exceed, or voltage should not go beyond or go beyond by way of maintaining the reactive power. What should be, what are the actions should see, thereby maintain the power quality. So these are some of the power quality problem perceived, common power quality. Now we are having importance of power quality. Here, first, the blocked capacity. What it means? Because of the presence of poor quality of the voltage or poor quality of the current, harmonic distortions in the current, harmonic distortion in the voltage, your conductor may not be in a position to carry the current what it was designed. The capacity we have to underutilize. That's why it creates blocks to the total capacity. The capacity is reduced. Say, for example, your conductor, say, for example, the Panther conductor is designed to transfer a megawatt of about 85 megawatt to 90 megawatt. If your current, whatever current you are passing through the conductor is as more harmonic, then it is very difficult to transfer the quantum of power what it was designed. You have to use only little lesser than the design parameter. That's why it's creating a blocking capacity. So this is because of the power quality. And then the equipment which are connected in the system, whether it's a transformer or reactor, whatever electrical equipment we are connecting to the grid, which has an impact, which has all these electrical equipments are designed to operate at fundamental frequency. But when you are injecting other than fundamental frequency of current, what will happen? This will create the damage. This will damage the electrical equipment often because of the thermal stresses. So that lead to premature failure of the equipment. Suppose, say, for example, the transformer was designed to serve its purpose for 25 years. Suppose because of the industry present in the particular area, which produces more of harmonic, that leads to more harmonic current and harmonic voltage. All this current and voltage are passed through the particular power transformer. What will happen? The design of the transformer is designed for 25 years, but it will get failed before 25 years. It may fail at 10th year or 11th year, all because of whatever the presence in the harmonics in the system. So the premature failure is all because of the power quality. The equipment may get totally damaged. Unplanned outage, sometimes outage may happen frequently because of the failure. All these things are happening because of the poor power quality, and power factor will also reduce. These are some of the reasons that's why we have to give to improve the power quality, what actions we have to take. Here, from the point of industry, say if your quality is not maintained, if your power is not in the quality power, If we are not delivering the power at 50 Hz, if we are not delivering the power within the voltage specified, if we are not delivering the power with fundamental frequency, it will lead to unsafe work environment. The equipment may fail. Equipment may operate a different way rather than what it was designed. It will lead to unsafe work environment for the person who is operating the equipment. Sometimes frequent failure of power supply, frequent interruption, long duration of outage that lead to worker may not be happy because he is not getting the power continuously. He may not be in a position to operate the equipments on continuous fashion. It will lead to frustration and turnover of workers. Suppose you are going to the industry, there is no power. If power is frequently switching on, switching off, that will lead to unnecessary outages. That will lead to frustration. Again, capital, that is also most important, because work, if you are producing continuous producing industry, in between if supply is interrupting, what will happen? So much of waste capital. You assume you are producing a mosquito net. While mosquito net is producing, in between power is interrupting frequently, what will happen? That will lead to work in process. All the work in process will be waste. That will lead to loss of capital, spoilage of semi-finished product, unscheduled downtime. These are some of the negative impact which is created in the industry just because of the poor power quality supplied by the power utility. That will lead to decreased energy efficiency and production loss is getting increased. Thereby, the overall the competitiveness of the industry is getting reduced. The output cost is getting increased because of the poor power quality supplied by the, and every consumer has to take care of the power quality to be maintained at the level what it is designed. You can see in the year 2018, Central Electricity Authority has conducted a study how the power quality has affected the Indian industries. Say, for example, they arrived the downtime, direct cost of downtime in India is about 3,128 million per year dollar. It's about 25,000 crores. Because of the power outages and poor power quality, direct cost of downtime of the industry leads to 25,000. If you think about 3,128 into put to the 75 rupee per dollar into 10 lakhs equal to 1 million. Put together, it comes about 25,000 crores. Per annum, the industries are suffering a loss of 25,000 crores just because of the poor power quality supplied by the utility. So out of 25,000 crores, if you invest 10%, say about 2,500 crores for the grid to improve the power quality, we can avoid this loss. The expenditure required to prevent such event from happening are estimated to be less than 10% of the financial loss. In the sense, 25,000 crores we are incurring a loss in the industry just because of poor power quality. Suppose if the power sector is ready to invest just about 25,000, 2,500 crores, we can be able to avoid such a huge loss. So thereby, both the consumer and distribution utilities can avoid such equipment failure in the grid as well as within the industry. All the equipment failures and quality problems can be discarded or removed from the grid just because by way of investing 2,500 crores in the industry for improving the power quality. This was the study of the outcome of the 3-year report. Think about the ST consumer. We are not much bothering about the lower level LT consumer. First, we will give focus for ST consumer because they are drawing power at 11 kV level, 22 kV level, 33 kV level, 110 kV level. EHT consumers, they are drawing at 110 and 230 kV level. What the problem they are facing? Many consumers, they are facing a voltage variation and they are also injecting harmonics into the grid, but no regulations properly specifying the limits. Even if the regulations are specified, the limits, but nobody is monitoring the implementation of the regulations. We will see one by one. This is the problem with the power industry. Some regulations are there, but nobody is giving much focus for implementing the regulation. Again, the regulation, it's vary from state to state, but there is no universal regulation for the entire country. These are some of the lacuna in the power sector. high cost alternate source. Suppose your industry is a continuous power industry, continuous production industry, you need continuous power, but the power utility is not in a position to provide quality power or continuous power. What you will do? You will find out alternate source. While you are searching for alternate source, if you are going for the high cost alternate source, it leads to end product cost increase. Due to voltage variations, many continuous process consumers are opting to go for captive generator at higher voltage level. This will lead to more usage of generators or otherwise more use of UPS, inverters. That will lead to cost of production will also increase. This is the negative impact of going other sources other than utility. Because when you are drawing from utility, it may be 4 rupee or 5 rupee. But if you are drawing from generator, it may cost about 12 rupee or 30 rupee. It is a waste of excess money. Again, measurement, verification, implementation framework. This is what we discussed. We have n number of different regulations for different states for the entire country. For the CES also in Central Electricity Authority also produced different regulations to power quality. But there is no uniform policy for the entire country. This is the point where now we are giving more focus. And then economic loss. Because of the increasing nonlinear loads system is causing high harmonic distortion resulting into failure of equipment. The failure of equipment is again, it is a loss to the utility, it is a loss to the industrial consumer also. Hence, we have to give more focus on power quality. Again, now we can see the utility has to put more stress on improving the system to bring more power quality, to better power quality or improve power quality. Say, for example, what action the utility has to do to improve the power quality. Suppose if you are doing network improvement, what it means? It is nothing but wherever the system is overloaded, we have to see that it should be optimally loaded. It should not be underloaded or it should not be overloaded. It should be optimally loaded. Suppose if it is a transformer, if you are overloading beyond 100%, what will happen? So life will be deteriorated. And over the period of time, the total life period will be reduced. So if it is underloaded, say it is a 20% load, 20% load, its asset cost is a waste. Again, loss is very high. So to avoid this, we should see that every transformer should be optimally loaded. So thereby, again, if power is in a circuitous path, we have to redraw the network. We have to reinvest. We invest more to create a new network to ensure power should be flown in a shortest path. Thereby, network improvement. By way of increasing the capacity of the transformer, increasing the capacity of the conductor, and putting appropriate devices at appropriate locations, we have to create more network. Create more network improvement, power quality will increase, power stability will increase, power availability of power supply will be increased. So network improvement is the first factor the utility has to take care to improve the power quality. From the customer point of view, if the customer is using more electronic equipment, what will happen? It will reduce the power quality. If demand is more variable, again it has a effect on power demand. To manage the system, that is a balance the supply with the demand. That is the toughest task. When there is a variability, it is very high. So power quality, if demand variability is not much, it is a stable demand, the power quality will be very. If the demand is high, the power quality may be in a position lesser than the expected one. So if the utility is having the position to ability to forecast the demand properly, what happens? Even though the demand is fluctuating or demand is highly variable, but your utility people are in a position to able to forecast the demand perfectly, they can able to manage the system very perfectly. That's why able to forecast lead to purchase of additional quantity of power from the grid, thereby we can improve the reliability of the system. Again, if we are putting a network improvement, that will reduce the technical loss. There is a transmission loss, distribution loss, put together T&D loss. In current practices, we used to call as a AT and C loss, aggregate, technical and commercial loss. All the losses we are grouping into technical and commercial. Aggregate, technical and commercial loss. In country, in India, it is about less than 21%. On those days, it was more than 25%, 27%. On an average, it is about 21 to 23%. In Tamil Nadu, it is lesser than 21%. In Tamil Nadu, it is for a distribution company, it is about 14%. For a transmission company, it is about 4%, put over 18% for the Tamil Nadu. All those losses can be reduced when you are making improvement in the network. So this picture shows the network improvement have the impact on the system reliability, power supply reliability and power quality. So the current day, the changing scenario, the lifestyle of the citizens totally depends on how much power he is capable of utilizing in daily life. That is the per capita consumption of electricity. Per person, per annum, how much quantum of power, how many units we are consuming. Suppose if you are in a city, you want to give a presentation. You want to sit, I say for example, I am sitting in the AC room. I am using an air conditioner. I am using a laptop. I am using a mobile phone. I am using all other gadgets for the purpose of delivering this presentation. It involves certain cost. Even if I am ready to provide cost, but the utility is not providing quality power. If it is not providing a reliable power, what will happen? The lifestyle is totally different. Even though I am sitting in a home, I am able to deliver the power just because of the power is available. Again, it's a quality power. And I am able to provide the delivery because of the equipment and gadgets available in my home. So the lifestyle depends on not only providing power, again the power should be a quality power. Because nowadays we are using non-linear loads. In this picture you can see laptop, whatever LED devices, and then modern cooking devices. All these devices are again quality power. So not only providing power is important, and also this quality power is most important for improving the lifestyle of the citizen. Again, you can see consumption per head per annum. As we discussed, consumption per person per annum. In India, it is about 1,181 units. Say, for example, in your home, you are living, so husband, wife, and two children, put together 4 persons are living. Say your bi-monthly consumption is 1,000 units. You assume bi-monthly consumption is, say, a normal family bi-monthly consumption is about 500 units. For a period of 1 year, 6 into 500, it is 3,000 units. For the year, it is 3,000 units. Say in your family, it's only 3 persons. It means per person per annum, you are consuming 1,000 units. For an Indian country, it's about 1,181 units per person per annum as of recent survey. Just 2 years back, 2017 end, they have taken this assessment. At that point of time, per person per annum in India, we are consuming on an average, it is about 1,181. First, think about the country, world average. As per 2014 record, world average is 3,000 units. Think about the developed country, Canada. They have 16,000. Person, those who are living in Canada, they are consuming about 16,000 units. Think about UK, it's about 6,000 units. USA, it is about 12,000 units. Australia, 10,000. It's again not only lifestyle, it is also depends on the climatic conditions also more. Because of the climatic conditions, they need more power. They have to utilize more power. In our country, because of our climatic condition, we need less power. But even then, if you provide more power, people will enjoy a comfortable life. In the sense, the world average is 3,000 units per person per annum, but Indian average is only 1,108. In the sense, if you want to match with the world average, you have to provide more power in future. Thereby, the people should consume in per person per annum. People should consume more electricity of 3,000 units. In the sense, they have to adopt modern gadgets in their home. You assume the current day we are using an induction stove, microwave oven, washing machine, all electrical equipment in the city. But what is happening in rural? They are using basic LED bulbs and basic inefficient devices in the home. Not all the devices what we are sophisticatedly we are using in the city. If every citizen is utilizing all those equipment, all non-linear equipments, what will happen? The power quality will deteriorate over the period of time. The utility has to design the system, has to build the grid to take care of all such loads in future. So recently, they conducted some study to assess what type of appliances people are using. especially in rural area, they are not even purchasing the basic appliances in the home. Country is the third largest consumer of electricity globally. Say for example, our per month we are consuming 1 lakh million unit for the entire country. Per annum it is about 12 lakh million unit. It is the third position in the world. Before us there are another two countries, but we are in third position with respect to consumption. But because of the population, we have 1 lakh 130 crores. Because of the population per person per annum, we are consuming only very minimum with respect to world average. We are the third in the power utilization. But because of the consumption, because of the more people, we are only one third only we are consuming with respect to world average. Again, if you think about 1,184 units per person per annum in our country average, but if you go to the rural area, but their average consumption is less than 500 units. The per capita consumption per person per annum is about 500 units in rural area. It means the rural people, those who are living in rural, they are not still using any modern gadgets. If everybody is utilizing modern gadgets, all of non-linear loads will create a more power quality problem. This slide shows mode of generation. We have to relate mode of generation poor power quality. Suppose 60% we are base load, we are thermal station, about 25% we are from renewable energy, remaining 10% from other sources, 10 to 15% from other sources. This is the present way of grid we are managing. If you are increasing more renewable energy, you are increasing the complexity. If you are putting more solar, more wind, it has an impact because the solar power produced in DC, which is going to convert it to the AC by the inverter. When you are introducing converters, it will have the impact on the voltage produced. Though your voltage supply voltage will be more of harmonics when you are integrating more, when you are inserting more of elements of inverters, more converters in the system. So again, the mode of generation affects the power quality what we are generating. So think about here, US, they have coal of 39%. In India, it is about less than 55%. In India, you think about the India, because it is 2014 record, it shows 74%, but currently it is about 54% only. Germany, you see, the coal, they are using 45%. Canada, coal percentage is only 9%. They are predominantly using, Canada is predominantly using hydro stations. Other generation, you can think about hydro. Canada is hydro maximum they are using. Italy, you can see other generation 24%, hydro 21%, 33% gas, coal they are using very minimum in the sense they don't want to spoil the environment by way of producing black power through coal-based stations. That's why they are preferring more of renewable energy. Think about Brazil. Brazil full of hydro power, 63% hydro, and other power plant it is 9%. Coal it is only 4%. But South Africa, nobody is going to bother. It's 93% from coal-based power plant. So likewise, you think about the Japan, they have only 36% of coal, but the remaining 40% from gas. So if you want to safeguard the environment, if you want to produce a sustainable power over the period of time, if you want to maintain the power, quality power, then you have to think about more of renewable energy. From the point of quality, it has some impact. We have to mitigate such things by way of introducing appropriate devices. We will discuss one by one. Now we are coming to propagation of harmonics generated by the non-linear load into the power system. We will see very clearly how we are propagating harmonics. The person who is utilizing non-linear load in his home or in his residential consumer or in its industrial premises is affecting the power quality of the supply voltage provided to other consumers. So you just think about, see this picture. Sinusoidal source voltage, it is a quality power. We are providing quality power at the point of common coupling point where the loads are connected. certain loads are linear loads, certain loads are non-linear loads. Linear loads, there is no much bother about the linear loads because we are not bothering about the linear loads. Customers with linear loads, because they are not much disturbing the system because they are linear loads, but because of the non-linear loads, customers with non-linear loads, they are drawing more of harmonic current. Because of this harmonic current, because of they are drawing more harmonic current, which is reflecting, which has the impact on the voltage at the common coupling point of common coupling point. Because of this voltage, it affects the voltage of the system voltage, thereby the voltage supplied to other customer is getting affected. Suppose you are running a industry which has a more of non-linear loads, but near to your industry there are very few houses which are using only very minimum of non-linear loads. Their full loads are maximum loads of linear loads, but they are getting poor quality power because voltage is very poor just because of the more non-linear loads present in the nearby industry. That's why at the point of common point, that is a PCC, point of common coupling point, the utility has to see the voltage should not be disturbed because of the poor power quality of the non-linear loads present in the consumer premises. That's why every consumer at the customer premises level, they have to ensure their harmonic current should not exceed certain limit. We have to fix the limit on harmonic current at the customer premises. Thereby, all non-linear loads should not draw more non-linear current from the grid, so which has the impact on the voltage. So as a utility, they have to put appropriate devices at different locations to ensure voltage to be delivered to all the consumers without any harmonics present in the system. So for the purpose of limiting the harmonics, limit the harmonic injection from individual customers so that they will not cause unacceptable voltage distortion levels for the normal system characteristics. So voltage, the harmonic injection by the individual customer has the impact on the unacceptable voltage levels. Here the question is who's responsible at what? Utility is responsible for providing clean voltage at every point of service premises. Every point the utility should ensure to provide quality voltage, clean voltage. Again, customer is responsible for not disturbing the current, that is not causing excessive current harmonics. So for that purpose only, utility is insisting all the customers to put appropriate filters in the customer premises to filter out all the current harmonics. Thereby, these harmonics should not reflect into the point of common coupling, which has the impact on the voltage of the system. Okay, so utility is responsible for providing clean voltage. Excessive current harmonics should be blocked by the customers. The customer is responsible to provide appropriate filters in their premises to ensure to block all the harmonics. Thereby, it should not have the impact on the point of common coupling point, which has the impact on the voltage. Now we are going to think about the effect of harmonics. What is going to happen on the equipment present in the system? The basic prime equipment, transformers. If frequency is increasing, with increasing frequency, with higher harmonics, naturally losses will increase. Losses caused by voltage and current harmonics depends on the frequency of the harmonics. In the sense, the losses due to fundamental frequency or losses due to third harmonics, losses due to fifth harmonic. If you think about it, when higher harmonic losses are very high, lower harmonic losses are very low. So we have to give more focus for controlling higher harmonic losses. Increasing frequency, since higher harmonics are more important than lower harmonic components in causing the transformer heating. Next to transformer heating, the important element is the neutral conductor. because of unbalance, non-linear loads, the neutral conductor current is getting increased. Normally in the balanced load, neutral current is getting cancelled because of the balanced linear current. There will be no harmonic current present in the neutral conductor. But when it is a more non-linear loads, neutral conductor current will be higher than phase current. That lead to damage of neutral conductor. The danger in excessive overheating of the neutral conductor. Excessive current in neutral conductor can also cause higher than normal voltage drops between neutral conductor and the ground conductor at the 230 outlet. Here the problem is the neutral bus bars and connecting lugs are sized to carry the full value of the rated phase current. Because the normally neutral current will be very minimum when it is a balanced without any harmonic. If it is unbalanced with full of harmonic, the neutral current is getting very high. That leads to neutral current conductor size should be matched with the phase current. If more of neutral current is higher than the phase current, then naturally the conductor will get affected. So again, to avoid this, they can become overloaded when the neutral conductors are overloaded with additional sum of triple and harmonics. To avoid this, what we are doing, the neutral bus bars, conductors, lugs should be designed to have a double cross section. Oversize we have to put to prevent such occurrence. That is a costly investment. So transformer side there is a problem, neutral conductor side there is a problem, and then electric panels. Electric panels are normally designed to carry 50 Hz currents. But because of this harmonic, higher frequency harmonic current, the panel boxes are getting resonant. When this happens, the panel vibrates and emits a buzzing. If you enter into the control room, in some of the area, they is full of industrial area. If you go to the substation which is located at the industrial complex, those substation, if you are entering, you will hear the noise of bustling noise. Why panel vibrates? All because of harmonics present in the industrial system, which refers on the vibrations of the panel. The panels also gets heated up due to stay and eddy current induced by harmonic currents. These are some of the impacts of the electrical equipments which are present in the system because of harmonics. And then cables. Cables that are subjected to ordinary level of harmonic current are prone to heating over and above what would be expected to RMS. If more of harmonic current, naturally cable burning will happen because of the impact. It's an impact on the cable. So put together, so distorted voltage because at the point of common coupling point, because of the non-linear load, it has an impact on the distorted voltage, overheated transformers and motors, heating of neutral conductors, low voltage at N loads, and high neutral to ground voltage at N loads. These are some of the common problems prevalent existing in most of the places because of the poor power quality or poor harmonics, effects of harmonics. Okay. Next we are coming. What are the solutions generally we are at present we are following for the purpose of improving the power quality? Automatic voltage control device, AVRs, we are placing at different locations to control the power quality. Active power factor correction. Power factor correction generally we used to place at the load center, customer premises, after the load center at transformer level, distribution transformer level, and then feeder level, and then substation level. These are the different locations we are placing power factor corrections. And then source and load balances. We are balancing the voltage and balancing the supply with the demand. And then we are going for digital substations and control and management of peak power, and then efficient reactive power plant. These are some of the things we are doing in the current day system to maintain the quality or improve the quality. With additional technology based systems, now we are thinking of static VAR compensators, static synchronous compensators at the transmission level, unified power quality conditioners and harmonic filters at the point of loads, which are from the point of technology. We are improving the quality by way of using SVC and STATCOM in the transmission level, UPFC and harmonic filters at the level of distribution levels at the consumer premises. And beyond that, thinking of exploring the possibilities of introducing energy storage systems at generation levels. Say for example, battery storage, pumped storage systems, Thereby, we are storing the excess power available at offload time in the battery or in the pumped storage. Thereby, power is made it flexible based on the requirement of the system. These are the way we can improve the quality of the system, quality of the power. Say, fax controllers, D-STATCOM, on-load tap changer, automatic voltage. These are the existing system we are following to improve the power quality in the utility. For example, STATCOM in Nalagarh, in Lucknow, the PGCL, Power Grid Corporation substation, they have a 300 bar 3 MVR STATCOM at Lucknow at voltage level of 400 kV. These type of STATCOMs, on those days, no STATCOM and all. Now, static work compensator and STATCOM are present on the power grid networks. Even the local Tamil Nadu grid network, we are proposing to incorporate such STATCOM in the 765 kV level, 760 kV substations level. Okay, now we are coming to harmonic limits. How much is permitted? What to do after if it increase beyond the permissible level? We will see one by one. Total harmonic distortion of current. That indicates the total harmonic current distortion of the waveform. This is with respect to fundamental current measure. What is total harmonic distortion? The fundamental current I1, all the component currents I2 square, I3 square, I4 square, I5 square, whatever harmonics we are presenting, that is with respect to fundamental current is nothing but a total harmonic distortion. Total demand distortion in the sense, all those currents with respect to fundamental current at the point of peak load. Suppose if you want to measure the power quality, the system power quality may vary when the system is fully loaded or if the system is underloaded. So if you want to penalize or if you want to incentivize, you have to consider only load point. At the peak load, what are all the harmonic components present in the system, you have to take care. That's why total demand distortion is nothing but square root of I2 square, I3 square, I4 square, I4 square divided by fundamental current at the time of peak load. So I2 square, I3 square, I4 square, I5 square divided by base fundamental current, that is the total harmonic distortion, total demand distortion with respect to load current. TDD, harmonics expressed as a percentage of load current. THD, harmonics expressed as a percentage of I1 alone. Here, what is the limit? What is the harmonic limit? Central Electricity Authority, they have a technical standards for connectivity to the grid regulation 2007. They fixed the voltage and current harmonics limit. Total harmonic distortion for voltage at the connection point, it should not exceed more than 5%. So no individual harmonic should not exceed more than 3%. The individual harmonic should be less than 3%. Total THD should be less than 5%. THD 5%, individual harmonic less than 3%. If the industrial premises, if they are maintaining THD less than 5% and the individual harmonic less than 3%, they should not be penalized. In the sense, they have to put appropriate filters in the premises to ensure THD should be less than 5% and individual harmonic should be less than 3%. If it is more than the limited, they will be penalized by the utility. This is the norms fixed by the CEA, Central Electricity Authority. Okay. Now we are coming to the harmonic limits for Tamil Nadu state. For voltage level of, we are giving more focus for HT consumers. For voltage level of 11 kV and above, Maharashtra, Tamil Nadu, Gujarat, all they fix 5% with individual harmonic content. 5% as a THD, as we discussed already, 5% for THD, 3% for individual harmonics. Whereas Karnataka, further stringent, they reduced THD as 3.5%. Total harmonic distance should be 3.5%, with individual harmonic current content not exceeding 2.5%. If you think about Andhra Pradesh, Madhya Pradesh, they have THD 8%. If you think about voltage 33 kV level, again the THD level further they reduce 3%. It means what it have impact. If you are reducing this percentage level further means we are improving the quality of the system. In Tamil Nadu, it is THD 5%, individual harmonic 3%. In Andhra Pradesh, Maharashtra, it is about 8% is permitted. You can see Gujarat 5% THD, single harmonic 3%. Similarly, Madhya Pradesh, Andhra Pradesh. In Madhya Pradesh, THD shall not exceed 1%. What it means? They are further stringent the measurements. Similarly, state electricity regulatory commissions at different states, they have their own regulations. They are saying fixing different level for THD and TDD. So, Central Electricity Authority, Central Electricity Regulatory Commission, State Electricity Regulatory Commission. These are the commissions or authorities. They are deciding the power quality regulations. They are fixing for different states. Now we are giving special focus for voltage variation and voltage unbalance because these two parameters are very important from the point of power quality. Next to harmonics. So far we discussed about harmonics. So on their limit. So what is fixed at different states? Next element is the voltage variation. How much is permitted? Say our voltage is 230 volts. Whether it will go beyond 230 volts, then it is permitted. Shall it go to 300 volts? If it is less than 100 volts, what will happen? Voltage unbalance. If you are driving a three-phase power, one phase voltage is 230, other phase voltage is 160, other phase voltage is 185. Is it allowed? Those things we should understand what we have to do. Say for example, the standards for voltage variation or fluctuation specified by the different selected states have been compared. For voltage level of 11 kV, Tamil Nadu specify the limit as plus 6% to minus 10%. Suppose if I am delivering a power of 11 kV, the maximum voltage variation is allowed is plus 6%. Minus side, minus 10% is permitted. The utility can able to deliver power at a voltage level of 11 kV with variation of plus 6% or minus 10%. In other states, it is a different point. Say for example, Tamil Nadu we discussed. If you think about Maharashtra, their percentage plus 10%, minus 12.5%. But Tamil Nadu, minus 10%, plus 6% only. But here, Maharashtra, they are saying plus 10% also. Similarly, for Madhya Pradesh, Maharashtra, Delhi, they have their own plus or minus variations are permitted. LT voltage variation, in the sense single phase or three phase, it's 6% to Gujarat, it is only plus or minus 6%. Maharashtra plus or minus 6%. Tamil Nadu plus 6%, minus 10%. Madhya Pradesh plus or minus 6%. So, plus or minus 6% in LT level. ST level is different level. Similarly, at EST level, 10% to 12.5%. That is, throughout the country, it is about plus 10% to plus or minus 10%. In Tamil Nadu, it is plus or minus plus 6%, minus 10%. Now we are thinking about the voltage unbalance between three different phases permitted. As per the Central Electricity Authority, voltage unbalance is permitted. It should not exceed beyond 3% at 33 kV and above. So allowed unbalance is only 3%. It should not go beyond 3%. This is the standard fixed by the CEA, Central Electricity Authority. Say for example, think about Madhya Pradesh. Their variation 2% for 220 kV, 3% for 132 kV. It means their regulation is slightly better than the Central Electricity. Central Electricity Authority fixed plus 3% unbalance. But here it is 2% for 220 kV, 3% for 132 kV. Now we are coming to the forum of regulators and then recommendation towards the power quality. All the regulators throughout the country, they formed the forum of regulators. So they are suggesting various improvements and they are putting so many recommendations to the government to improve, to introduce certain things in the power sector to maintain or to enhance the power quality. Say, for example, what are the power quality issues? Frequency deviation, voltage interruption, voltage transient, voltage dips and swells, voltage sags, voltage unbalance, flickers, harmonics, over or under voltage. These are the common power quality problems in the system for which the forum of regulators has introduced lot of regulation, lot of recommendations. We will discuss one by one. Say, for example, Kerala State Electricity Regulatory Commission, they introduced a regulation to maintain the power quality for distribution system in the year 2019. Likewise, every state, they introduced their own regulation to maintain the power quality. But countrywide, there is no uniform regulation. So someone should take care of the entire countrywide uniform regulation. That is the first recommendation. We can see one by one. Need for power quality recommendation. Power quality recommendations. Regulations. There is the immediate need. Need of the day is the central government has to introduce some regulation to maintain the power quality throughout the country, because every state utility is maintaining their own recommendations, their own regulations. So there should be uniform regulation throughout the country. So that is the first recommendation given by the forum of regulator. And then, should reliability indices be part of PQ regulations? Whether the quality alone is sufficient? Shall we introduce reliability indices, SIFI, SID? Such reliability indices can be incorporated. That should also be incorporated. That is the second recommendation given by the forum of regulator. And then, what are all the location? Which are all the location where we have to monitor the power quality? Whether to monitor the power quality only at the consumer premises or to monitor the power quality at the substation level, or monitoring the power quality at the transformer level, or monitoring the power quality at the feeder level, or monitoring the power quality at the generation level. Where to monitor? Whether at distribution level, or at consumer premises level, or at transmission level, or at generation level. Such things are to be taken care. So monitoring of power quality parameter. What are all the parameters to be monitored? That is, which power quality parameters need to be specified in the PQ regulation. Whether to monitor everything, or we have to give first instance what are the parameters to be given more important. Such things are recommended to the central government by the forum of regulator. Actually, if you go to the Google, there is a report called Indian Power Sector Issues. That is if you go to the forum of regulator, they produced a book about power quality issues in India. If you go to Google, type forum of regulator, go to the forum of regulator. In the forum of regulator, they released a recent book about what are all the problems the country is facing with respect to power quality and what are the recommendations to improve the power quality. This is just about 180-page report. If you study the entire report, you will get all those information, whatever I am providing. So, whatever information I am sharing is available through the Google only. So, I collected from various forum of regulators and various State Electricity Regulatory Commission and Central Electricity Regulatory Commission, and then I referred APFC. So many other agencies I referred to give a combined presentation. So first is what are all the parameters we have to monitor, and what are the locations we have to monitor, and where to fix the power quality monitoring devices, and then whether to give incentive and whether to give a penalty mechanism. Suppose the utility is not providing a quality product. I am building a wonderful house, keeping all the electronic equipments, all high sensitive equipment purchased at high cost. Suddenly everything is not performing well because of the poor quality supplied by the utility. The utility has to be penalized. How much to be penalized? Likewise, the utility is providing good quality power because of your injection of harmonics into the system, because of the non-linear loads present to the industry should be penalized. Such way of incentivize or disincentivize mechanism to be developed for maintaining the power quality. This is discussed in the form of regulator. And then now everywhere, now we are converting our power grid into smart grid. How the smart grid will be really smart when you are maintaining the power quality. What are the things we have to maintain? Such things are recommended to the government in the form of regulator. And then database, we have to maintain the database. Suppose if you are opening the steel industry, what will happen with respect to the power quality in the neighboring area? Say, for example, Tata is going to create a new steel industry. So whatever capacity which has already created with the Tata, what is the problem with the power quality? Based on those data, we can replicate and we can control the power quality issues before the industry is coming or after the industry is coming. So thereby we can maintain the system for which power quality database is important. Someone should maintain the power quality database of the entire country. And then people should be sensitized. The people, those who are working in the power sector, the utility people, the academicians, the industry people, those who are working in the industry, have to be sensitized. For that purpose, we should give an awareness training program on importance of power quality. Why power quality is important? Such things to be disseminated across the industries. Thereby, the people, those who are enjoying the power, will try to maintain the quality of the power. At the same time, the people, those who are providing power, they will also try to maintain the quality power. And then conducting audit at regular interval, at industry level, at utility level, someone should conduct the like energy audit. They should conduct the power quality audit to ensure quality is maintained at all time. These are some of the regulations. Power quality forum of regulator given some recommendations towards maintaining the power quality in the country. So now we are coming to how to enhance power quality by way of introducing IOT into the system. Application of IOT to enhance power quality. Say, I think you all know what's the difference between data, what's the difference between data, information, and insight. There is a movie. In the movie, comedy actor Sendil, the other person, the other student, all they were sitting in the temple. Say, I think the movie is a boys, Tamil movie boys. In that, uh, comedy actor Sendil is talking to the next actor, saying that I have a book. In that book, we have a lot of information, lot of data. In which temple, which prasadam is available on which date, at which time. This is the book. Information is my power. So data. Suppose if you have a data, it is a raw data. Raw data is not going to have any impact. Suppose if the data is put in a proper format, if it gives some information, suppose in the particular movie, boys, the comedy actor Sendil is taking a book from his pocket. He is a beggar. He is taking a book from his pocket, stating that this book contains the complete information about in which temple we will get what type of prasad. Say for example, you need curd rice. Go to Mundakanniamman temple at 12 o'clock. They will provide. Suppose you need pongal or sambar sadam. You go to the Sai Baba Kobil at Mailapur at morning 9 o'clock. You will get sambar sadam pongal. Likewise, in which temple you will get what prasadam. Such information is available in the book. So data, you are collecting data and making it as an information. Again, based on the information, action to be taken. Suppose the person is coming and asking, I am very hungry. I need some non-veg food. Immediately, based on the book, you can say, if you go to say Muniyappa Swami temple, say today Saturday, they will provide a non-veg food at free of cost. That is a prasadam. Likewise, the data, raw data to be converted into information. Based on the information, some action has to be taken. This is the fundamental for application of IoT. IoT is nothing but Internet of Things. We will see, we will go one by one. The Internet of Things is the network of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, actuators, and network activity that enable these objects to collect and exchange data. What it means? The simple way we can say it's a network of physical objects. Suppose I am residing in my home now. You are residing in your home. We have to interact. What way we are interacting? Just by way of my mobile phone or my laptop is connected to internet. Your laptop is connected to internet. So I am talking through my mobile phone. You are receiving through your laptop. My object, I am one physical device. You are another physical device. We two are interacting by way of when both are connected to internet. Likewise, all the physical objects, whether it is a transformer, whether it is a breaker, whether it is a lightning arrestor, whether it is a conductor, whether it is a generator, whatever equipment which are utilized in generation, transmission, and distribution, all the equipments, if it is connected to the net, then automatically there is a possibility of exchanging of information, exchange of data from the sensors which are fitted with the object. So here only we are coming data to information, information to insight. All the data captured by the sensors will be sent to the control room, where it will be assigned, arranged as a information. Based on the information, the action will be taken by the artificial intelligence network or whatever algorithm we have. Say for example, if the transformer is overloaded, we have to remove the loads, or we have to keep the transformer within the level, means certain loads to be switched off. So for that purpose, the loads to be sensed. The sensors which are fixed on the transformer to continuously monitor the load on the system. So based on the data what it supplies to the central control room, the observer arranging the data, it will come to the conclusion that the load is going beyond the permissible limit. Some action to be taken, the artificial intelligence network, that will take care of what action to be taken. So data, information inside. This is nothing but the IOT. IoT describes network of physical objects or things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other systems. So I am connecting with the internet, so that you are also connecting with the internet. Thereby, I am transferring. We are exchanging our informations, our data with other system over the internet. This is nothing but the IoT. So ultimately, all the digital technologies, what purpose we are introducing? Overall, we want to reduce the cost of power. Ultimately, we have to reduce the cost of power. That is our prime objective is overall cost of power should be reduced. Second is the need to maintain variability and needs to increase the reliability and quality. Power to be provided reliably and power to be maintained at a quality level. These are the prime objectives. Whatever digital technology we are introducing into the grid as a smart grid, IoT applied grid, all those things for the purpose of reducing the cost of energy in the sense operation level, we have to reduce the manpower requirement. Operation level, we have to protect the equipment performance and we have to avoid the damage of equipment. Thereby, overall cost of the power should be reduced. That is the prime objective. Second, need to maintain the variability. Demand, when there is a variation in demand, supply to be matched accordingly. Thereby, supply and demand should be managed efficiently and effectively. And then reliability, how without any interruptions, even if it is getting interrupted, quickly we have to restore the power, the reliable power, quality power. These are the three prime area which are the objectives behind the implementation of digital technology into the power grid. Now we are coming to the IoT in grid management. Here you can see, by placing sensors at substations and along the distribution lines, companies can gather real-time power consumption data. Suppose if I am placing a sensor in your home, it is giving complete information about your power consumption. Based on the data, I will come to the conclusion that what is your pattern of consumption, what are the types of your load, at what time your power factor may be varying, at what time you are maintaining the uniform power factor, uniform unity power factor, at what time your power factor is very low, when you are consuming more of usage of non-linear loads. All those information interpretation we can arrive based on the data sent by the system which is fixed in your home. Likewise, energy company can take a better decisions about voltage control, load switching, network configuration based on the sensors fixed at all the elements present in the power grid. Similarly, smart switches, outage monitoring, rerouting the power usage data during load forecasting time, managing the overload along the transmission lines, how to maintain the frequency and voltage control, power consumption data, where to build the data, where to build the power infrastructure, additional requirement, all those informations, all those conclusions, all those decisions we can take based on the data supplied by the sensors placed at all the equipments. Here you can see benefits of IoT based smart grid deployments. First, the prime objective is reducing the overall transmission and distribution losses. How it is possible? Since you are continuously monitoring the elements present in the transmission system and distribution system, you are coming to the conclusion that where the losses are happening, where it is at higher level, where it is at lower level. So you have to focus, you have to give more focus on at high losses level, where you can introduce elements to control the losses, and you have to take appropriate actions to control the device, control losses. Thereby, on an average, overall, we can reduce the T&D losses. Peak load management, improved power quality of supply and reliability. That is also the benefit of the IoT-based smart grid deployment. And then unnecessary power purchase we can avoid, because we can flexibly manage the infirm power for the purpose of fulfilling the demand. Better asset management, all the assets to be appropriately, optimally loaded. Without optimally loading, we are not bothering about. Sometimes we are overloading, sometimes we are underloading. By way of IoT devices, we are continuously monitoring the utilization of the individual assets. Thereby, we are ensuring no asset is underutilized or no asset is overutilized. Thereby, all the asset in the sense, whether it is a transformer or it's a breaker, whatever assets we are utilizing, everything is optimally better utilized. Thereby, asset life is maintained. Increased grid visibility and self-healing grids, renewable integration, accessibility of electricity. These are time of day tariff, demand reduction program. All those things can achieve, provided if you are applying IoT system into the smart grid system. Say now we are coming, what is meant by IoT system in smart grid? You can see there are two networks here. One is data network, the other is the electricity grid. One circuit is a data transfer, say for example, wind power plant, solar power plant, fossil fuel based power plant, combined heat power plant. Left side full of power plants, right side full of loads. There are only two things. One is a generation, the other is a demand. Generation means different type of power plant. Say base load power plant located at limited level, distributed generations are located at different areas. Let's say distributed solar and wind generations are located at different levels. Distributed generations, hydropower plant, thermal power plant, base load power plant located at very limited locations. So this is left, right, different things. Electric vehicles. Again, vehicle may not be in a single position every day. So today it may be in Trichy, tomorrow it may be in Madurai, day after tomorrow it may be in Coimbatore, or tomorrow it may be in Chennai. So how the electric vehicles are moving, how the loads are moving, based on the sensors, we are coming to the conclusion where the load is present at present. So by way of seeing the history, we can conclude on first week where it will be, second week where it will be. Generally, those algorithms, those pattern can be generated by way of continuously collecting the information about the assets, loads, right? Smart building, electric vehicles, common and commercial and industrial applications, and smart homes. These are the loads. All these generations and loads are connected in a power grid. That is the first circuit. Second circuit, data network. All those informations, the data from the power plants, data from the load centers are all interacting with each other by way of connecting to the internet. Thereby, both generator as well as consumer will get a benefit of IoT. We will see one by one. You can see this picture. It's clearly, very clearly giving IoT pillar of a smart grid. What it means? Say, for example, transformer monitoring. I want to ensure my transformer to be optimally loaded. It should not be underloaded. It should not be overloaded. In the sense, what is the current flowing through the transformer? What is the designed parameter? Say it is 100 MVA. Suppose, for example, the transformer which is located nearer to your home, it is called distribution transformer. Say about it is 100 kV. It may be either 100 kVA or 250 kV generally. You assume it is 100 kVA. 100 kVA divided by root 3 V, what is the voltage level, put current, what is the designed current. So that is the maximum current we can load. If your load current is less than the designed current, your equipment is underloaded. If it is going beyond, it is overloaded. What is optimally loaded? 80 to 85%. If we are loading, it is working performably. Every microsecond, we are monitoring the current. If some point of time, say in the evening around 7 o'clock, midnight about 11 o'clock, because of the air conditioner during summertime, because of the evening loads during normal days, if the evening load is more high, the transformer may get overloaded during off time, during peak time. Then what we should do? At that point of time, how we can bifurcate? Can we put an additional transformer or can we increase the capacity of the transformer? Such decisions we can take based on the input what we are receiving from the transformer to the control room. Instead of going and measuring every time, if you are drawing those information continuously by way of IoT devices, placing the proper sensors and collecting the data from the individual devices to the control center, we can take appropriate decisions. Likewise, you can control the switch control and line regulator, substation metering, because if you are putting a smart meters in all the locations, we will come to know what type of RT power is going, what type of reactive power is going, what is the power factor, what are the other elements which are very important for maintaining the power qualities. Those things we can easily manage if you are fixing a smart meter in all locations, at all locations. Similarly, workforce management. Suppose there is a breakdown. You want to divert group of people to the location where the power should be immediately restored. We can immediately divert if the person, the substation team, the workforce management team, their vehicle, which can be tracked based on the vehicle location, they can reroute the people to go to the critical location at first instance. By the way, all the equipments, all the devices, all the physical objects present in the power grid, present in the grid, have to interact with the internet by way of embedded sensors in the devices, in the physical objects. Thereby, we can get the data, first data. Data can be arranged, information can be created. Based on the information, we can take an excellent decision. That is nothing but a IoT. So nowadays, gradually IoT is picking up in smart grid implementation. So with this, I am finishing my presentation. Now it's time for question. Thank you, one and all. Thank you, Professor.
Thank you, Balamurali sir, for your valuable, very informative session. Now, dear participants, kindly ask questions. Question and answer session will be followed. Dear participants, kindly post your questions or you directly inquire your doubts with the resource persons. Sai Kumar sir. Sai Kumar.
Actually, here there is a question on what basis THCs are fixed by the different states. generally here, it's 5% and 3%. We are fixing a THD at 5% at the overall level. Individual harmonics, it is 3%. In almost all the states, if you are raising the standards, say instead of 5%, if you are reducing 3%, it means you want to improve the quality. In all India level, it is fixed at 5%. Again, all those fixing of parameters are based on how quality we can monitor, how quality we can measure, and what are all the equipments or devices are available in the active filter level to control. These are the area we have to give focus, thereby to decide the THD level fixing. Actually, here filters, there is one question, distribution level. Now, generally, harmonics are filtered at customer premises level, because utilities responsibility is only to provide a clean voltage. Harmonic currents are injected by the load centers, load customers. So that's why we are requesting the consumer to maintain the THD level, thereby by way of putting the appropriate filters in their premises. So utility's role is to ensure voltage, clean voltage alone.
Hello.
Yes, please.
Balamurali sir.
Yes, please.
Kindly brief about any fax devices available in Tamil Nadu, sir. Fax and custom power devices available in Tamil Nadu electricity board, sir.
Actually, now
both
we
the
are
transmission distribution side or in SCADA center. We have seen only in Madurai, Tamil, Chennai, no, sir.
Actually, here the most of
Brief
the
about that,
northern
sir.
grids,
Few minutes.
most, say for example Lucknow, we already shown the presentation that Lucknow and other most of the power grid stations now they are introducing more of STATCOM only. Now only here in Tamil Nadu at near Kallakurichi and near Chennai, North Chennai, they are going to introduce a STATCOM and reactors in the upcoming stations of 760 kV, 760 kV session only, because of long distance lines at high voltage level. They are thinking of introducing STATCOM and reactors alone, not any other devices like SVC or any other device. But SVC under active consideration by the power grid to introduce. As of now, STATCOM is available in many places of power grid network at 400 kV level alone, not at even at 230 kV level.
Harish Kumar.
Thank you, Balamurali sir.
Okay, sir. Thank you, Professor. Thank you very much. Thank you for permit me to interact with you people and all.
Thank you very much for your very valuable informative session, sir. For all the 3 STTPs, you have shared your knowledge from TNEB. Once again, I thank you very much, sir, for your contribution to our STTP, sir.
Okay. Thank you, madam. Thank you very much. Thank you, Professor. Thank you. Bye.